morning, children. In today's lecture, we will be understanding the different aspects of magnetic effects of electric current. Now, first of all, before beginning the lecture, we would like to make you understand the statement. What does this statement says? That magnetic effects of electric current. That means whenever a current is flowing through any conductor, is there any kind of magnetism involved in it? This is a big question. Lots and lots of scientists have put on their efforts, put on their lives even to understand this, and lastly they got actually one relation that whenever, say, this is a current carrying conductor, okay, now the plus q charges, that is there is a flow of charges over here, that means the current is flowing in this direction, right? The current is flowing in this direction. So, whenever the current is flowing through the conductor, by default it has been seen that it is associated with a magnetic field. For example, if I take this pen as a current carrying conductor, and from this finger the direction of electric current is towards the cap of this pen, then the side along with this plane we are having the magnetic field, and this is by default. Whenever there is a electric current passes through any circuit, by default there is a magnetic field, and especially I am talking about a DC current, okay. Because a DC current is a stable current, you will understand all the things in the coming lectures, that what is a DC current and what is an AC current, but for the time being just have the thing in your mind. Direct current is that current which flows continuously, so that you may have a continuous magnetic field, okay. So, the magnetic field is there along the sides of the conductor. Now, before going into the details of it, just I will give you a brief information about what is a magnetic lines of force, or rather what is a magnet. Okay. Now, we have been playing with magnets since childhood. You might have been using the magnets on your refrigerators, as well as you might be sticking on some sticky notes over your almirah, chest, etc. But years ahead, when it was discovered, I am not going into the details of the discovery of magnet, but we have seen that a magnet is somewhat like this, okay. With one side we are having N and the other side we are having S. What are these N and S? These are the north pole and this is the south pole, okay. This is the south pole of the magnet. Now, when you also might have seen that whenever you are having some iron nails or something and you bring the iron nails towards the magnet, at a point the magnet actually snatches the iron nail away from your hand and it gets itself stick to it. So, that region where the iron nail feels the power of the magnet or it feels the effect of the magnet, the entire region is known as the magnetic field. So, now we will see in this magnet how this magnetic field works. The magnetic field, say if an iron nail is over here, it is not being attracted or it is not coming down to the magnet. But if you put an iron nail over here, it immediately is being attracted by the magnet. Why? Because it lies within the range. So, we can say that this is a magnet and the entire area, this much area is being influenced by the magnet. That means whatever object comes within this periphery will be attracted towards the magnet. So, the area where the means essence of the magnet or the presence of the magnet is felt, that area is known as the magnetic field. Now, we will see in terms of physics how this magnetic field works. If we have a magnet like this and we have a compass Okay, you know the compass is a small instrument, is having a small needle, it is a magnetized needle, and it is used to get the directions, like we get the directions from the north and south. They are being used by the navigators over the years and centuries. So we will take that simple small compass and we will start putting over here. When we put over here, it points in this direction. We will continue direction wise, we will continue to rotate the compass and we will see that it actually turns out in this fashion. Okay, if we do in this direction, we will also see over here that the compass points in this particular array. Okay, now what is this? This is the movement of the compass, and with this movement we can get that this way the magnetic field is generated in a magnet outside the magnet. Okay, this is being generated outside a magnet. So the magnetic field lines, they start from north and they terminate, or they originate from the north of the magnet and they terminate at the south of the magnet. It is both way, up and down, and we see that these are in the form of circular loops. So these forms your magnetic lines. Okay, so this is how we see the magnet. Now can we come down to some of the important properties, of magnet. Okay, what is the magnetic things? In outer space, magnetic field lines are from north of the magnet to the south of the magnet. This is the first point which we have. That means the magnetic field lines start from the north and they originate from the north and come down to the south. Now the second point, what happens inside a magnet? Now you see students that it is coming over here, it is having a direction from north to south, but inside the magnet it is going to form the continuous loop. What happens inside? It is going in this fashion, this fashion, this fashion, and again in this fashion, just coming over here, coming over here. That means inside the magnet, the magnetic lines of forces are arranged from south to north. We can have a second point. Inside the magnet, the lines of forces, that is the magnetic lines of forces, are directed from south to north. These are the two basic important points with the magnet and the magnetic field. Third thing, we have seen all magnetic field lines are forming, what they are forming, students? Yes, you are right, they are forming circular loops. Yes, that's it, they are forming circular loop. If we continuously see, it is forming a circle. It is forming a circle over here. Okay, now so many small lines. Are the lines cutting each other? What do you see? We see that yes, there are lines, but no two field lines intersect. No lines intersect. Every field is having a distinctive line and no field intersect. Okay, then outside the magnet we see that near the poles, what we have? Near poles we have strong magnetic field. Strong magnetic field. Near the poles we are having very strong magnetic field, that is over here at this part, and as we go further away from the magnetic field strength decreases. The more we come towards the magnet, we have a very strong magnetic field, and the way we go out from the magnetic field means we go further, the magnetic field decreases. Similarly, what at these points, these are your polar points, at these 2 points we have a very strong magnetic field. Now the question is, what happens inside the magnet? Here we are having somewhat magnetic field lines is coming, going, having a different kind of strength, but over here inside the magnet we see these are parallel lines. These are parallel lines. So another point is, inside the magnet we have a steady magnetic field. Okay, we have a steady magnetic field. That means inside the magnet, if we can use this magnetic field, definitely we will be using this kind of magnetic field in the various devices to come, because it is offering a very steady magnetic field. There is no increase, there is no decrease, there is no fluctuations in the magnetic field. So in that case we can use this steady magnetic field for various other things like the generator or in your dynamo, right? We will be studying that later, but for the time being understand that over here we can have a variable magnetic field over here, but inside this we have a very constant, we can say a constant or a steady magnetic field is flowing from south to north inside the magnet. So these are some of the points which we are having for magnetic field. Now another important point which comes, that we know that Earth is a big magnet. Okay, Earth is also having a magnetic field of its own. Now if we are using a magnet, won't the field of Earth maybe affecting the magnetism? Yes, it does. There is one point where, but inside the magnet we see the magnetic field lines over there, it is also influenced by the Earth magnetic field. But say this is a point where we can have two equal magnetic fields, like Earth is also exerting a magnetic field, say minus B, and this magnet is exerting same magnetic field from this direction as plus B. Okay, so we see that at this point, at this particular point, we are having the value of this magnetic field as well as the value of the Earth's magnetic field, but both are equal and opposite in nature. As we see that both equal and opposite forces cancel each other, so both these magnetic forces will cancel each other, and at this point you have a zero magnetic field, neither from the Earth nor from the magnet, and this point at which there is no magnetic field felt or both field cancel each other is known as the null point of the magnet. So these are some of the basic things about magnet, and at the null point we are having a zero magnetic field. Okay, now following these simple things about your magnet, we will be focusing ourselves onto the magnetic effects of electric current. We will see how the magnetism appears and whenever the current is flowing. Okay.